we're going to talk about arithmetic sequences. So arithmetic sequences are a string of numbers where in order to get from one number to the next number, you either have to add by a common number or subtract by a common number. The formula is given to you on the reference sheet, and that formula looks like a sub n equals a sub 1 plus my common difference times n minus 1. And that might seem like a lot, so let's break it down. A sub n is going to be the nth value that they're asking for. So for example, they might give you a string of numbers and then ask you to find the 50th number in that string. Well, instead of sitting there and writing out all of the numbers, what you can do is make a formula and then work from there. A sub 1 is going to be whatever the first value in that sequence is going to be. So this is our first initial value. This letter D is standing for our common difference, which means whatever number you're adding or subtracting by each time to get from one number to the next number is going to be there. If it's positive, we're going to put a plus. If it's negative, we're going to put a minus. And then this letter N would be where they are asking you for the, let's say, 50th term. We would put in a 50 in that place. So let's take a look at a couple of different types of examples that could be asked of you. So in an arithmetic sequence, the first term is 25 and the third term is 15. So what I like to do, just based off of reading that, is kind of set up, okay, this would be my first term, my second term, my third term. Okay, so my first term is 25, my third term is 15. When you have it written out that way, sometimes it helps to see it in a little bit of a better light. And it's asking, what is the 10th term in this sequence? Okay, so we ask ourselves, are the numbers going up or down? As you can see, the numbers are going down. Okay, that's a little bit of an indication to you that choices 3 and 4 are already out, because our string of numbers is decreasing. So if they want the 10th term, that means we have to go down and get lower numbers. Now, you might say to yourself, what is that common difference? Well, I have to go from 25 to something to 15. Well, that number in the middle has to be 20, which means that I'm subtracting by 5 each time. So that's your common difference. So I want to find the 10th term of this sequence, and I'm going to do that by taking the first term. My common difference is that negative 5, and I'm going to multiply it by the 10th term minus 1. Okay, because we're always applying that common difference to the number right before it. So I'm going to type this in the calculator exactly the way that it is shown. Okay, not necessary to try to do bits and pieces of it and put it together. Just do it all at once. And you see that you get negative 20. Let's take a look at another example. In an arithmetic sequence, the first term is 4 and the third term is negative 2. What is the common difference? So this is not asking you to do anything more than find that common difference. Now, here's how you can do this. Well, we know that the first term is 4 and the third term is negative 2. And what we can do is kind of find the difference between the numbers over the difference in their places. So I'm going to write that down for you. The difference in the numbers divided by the difference in their places. So for example, the two numbers, and this is very similar to slope. Hopefully you recognize that. Negative 2 minus 4. I'm finding the difference between the negative 2 and the 4. And you've got a number in the third position and the first position. We do know that our common difference has to be negative because our numbers are going in decreasing order. So negative 2 minus 4 is that negative 6. And 3 minus 1 is 2. When you divide those, you get negative 3. So that's our common difference. The number in between 4 and negative 2 would be a 1 if I'm decreasing by 3 every time. Let's take a look at another example where it's asking you to first find the common difference and then determine the 21st term of the sequence. We're going to apply that same method we used in the last question to help us find our common difference. So we're going to find the difference between the actual numbers, so 17 minus 5, okay? And we're going to find the difference in those positions. Well, we have a number that's in the 5th position, and we have a number that's in the 1st position. So you kind of want to make sure that you are putting the correct numbers underneath. Since 17 is in the 5th position, that's why the 5 is under the 17. And since 5 is in the 1st position, that's why the 1 is under the 5. Okay, 17 minus 5 is 12. 5 minus 1 is 4. And we want to simplify that to give us 3. It's a positive 3, which means that our pattern, we know, is going in increasing order. So now we want the 21st term of this sequence. So as a reference, that formula was we take the first term, we add the common difference times n minus 1. So I'm looking for the 21st term. My a sub 1 value is that first term, which is a 5, plus my common difference, which we just determined from the first part, which is a 3, times 21 minus 1. All right, so I'm going to do 5 plus 3, parentheses, 21 minus 1. And press enter. That gives you 65. So I know the 21st number in this sequence is going to be a 65. Okay, let's take a look at another example. Last one. The equation that represents this sequence is... So if you look at the 4 answer choices, we've got a lot of the same numbers, but they're in different places. And so that is really where knowing what the formula represents is going to help you understand the question. As you can see, they all have this n minus 1 attached to the end. So that's not really making any sort of a difference. This number that's right in front of there is what we're representing as our common difference. So we need to find what our common difference is. Well, to get from -2 to -5, I have to subtract 3. If you notice, that pattern continues along all of those numbers. Okay, so that means that in the orange highlighted, I have to have a -3. Well, there's only one answer choice that has that. Let's double check why 2 is also correct. This number here has to be the first term in our sequence, and it is your first term. So little things that really together can make or break whether you get a linear, an arithmetic sequence question correct.